So today we have a very beautiful geometrical problem. We take a square. Now inside the square we inscribe two more squares in a particular pattern, as you can see in this diagram. Now the point to be noted over here is that this particular line AB is a straight line. Now if the area of this particular square is 5, the area of this particular square is 20, the question over here is to find the area of the biggest square. So this is Anmol, and now let us see the solution. How can we find the missing area? Okay, now let us start with the solution. So the first thing that we are going to do is we are going to utilize the fact that area of these two squares has been given. So recall that if there is a square whose side length is equals to s, therefore the area of the square would simply turn out to be s square. So the same concept can be used over here. So for example, if we take the side length of this bigger square as a variable x and the side length of this smaller square as a variable y, so what can you say about the values of x and y? So we can see that area of this particular square is equals to 20 and the side length is equals to x. This means x square would be equals to 20, and taking square root on both of the sides will give us the value of x, and that would be square root of 20, and this thing can be written as 2 times the square root of 5. Okay. Now similarly, the area of this particular square is equals to 5 and the side length is equals to y. Therefore y square would be equals to 5. This means the value of y is going to be square root of 5. So now we can see that if the area of this particular square is equals to 20, this means the side length of this square has to be 2 times the square root of 5. Similarly, the area of this particular square is equals to 5. This means the side length of this particular square is going to be square root of 5. Okay. Now let me just erase this thing and mark some of the other things inside this diagram. So first of all, we will start marking the angles. All these angles would be 90 degree because they are the corners of the squares present inside this diagram. Okay. Now look in this right angle triangle. In this right angle triangle, I will mark this particular angle P as equals to theta and the angle Q as equals to alpha. So now look carefully. For this right angle triangle, we have three angles, theta, alpha and 90 degree. So therefore in the triangle PDQ, we can say that theta plus alpha plus 90 degree is going to be 180 degree, and this is because of the angle sum property that says that the addition of all the three angles of any triangle is always 180 degree. Okay, so keep this equation as it is because it is very useful. Now look carefully at the point Q. First of all, we can see that the point Q lies on a straight line, and at the particular point the angles are getting divided into three parts. One of the part has a value alpha, the other has a value 90 degree because it is the corner of this particular square. So what can you say about this third angle? So the thing is very simple. Here one of the angle is alpha, the other angle is 90 degree. So this angle, let it be something like beta, and as this line is a straight line, we can say that alpha plus 90 degree plus beta has to be 180 degree. When the sum of these three angles would be 180 degree, then and then only this line can be a straight line. Now compare this pink equation with this blue equation. We can see that alpha plus 90 plus theta equals to 180 in this equation, and this equation says that alpha plus 90 plus beta equals to 180. So by simply comparing these two equations, we can say that theta is equals to beta. So over here we have taken this particular angle as equals to beta, so I will just replace that thing as equals to theta. Okay, so here we can replace this angle as equals to theta. Now look carefully in this right angle triangle. In this right angle triangle, we can see that one angle is 90, the other is theta. So what can you say about this third angle? So let me just clear this thing over here. So the third angle for this right angle triangle would be this particular one. So what can you say about the value of this angle? So again, take help of this equation, theta plus alpha plus 90 equals to 180. So for this right angle triangle, if we apply the angle sum property, the value of this angle will turn out to be simply alpha. Again, we have a straight line, one angle is alpha, the other is 90. Therefore this third angle would be equals to theta. Now for this particular right angle triangle, let me just make this thing a little thin. Now inside this right angle triangle, one angle is theta, one is 90 degree. Therefore by using the same first equation, we can say that the value of this angle is equals to alpha. So here we have marked some of the angles inside this diagram. Now let us mark some of the side lengths. So the length from point P to D, I will take it as a variable A. The length from D to Q, I will take it as a variable B. Now the length from B to R, I will take it as a variable C, and the length from S to B, I will take it as a variable D. Now look carefully, the question is to find the area of the square ABCD. So what I will do is I will simply take the side length of the biggest square as a variable x. Okay, so now ultimately in order to get the answer to our problem, we need to find the value of x square, because that is ultimately equals to area of the square ABCD. Okay, so now look carefully over here. The length from D to C is equals to x, the length from D to Q is equals to b. Therefore, the remaining length, that is from Q to C, will simply turn out to be the longer length minus the shorter length. Therefore, this length would be equals to simply x minus b. Okay, now as the quadrilateral ABCD is a square, all the four sides would be equal, and therefore the length from B to C would also be equals to x. Now the length from B to R is equals to C, the length from B to C is equals to x. Therefore, the remaining length, that is from R to C, will simply turn out to be the longer length minus the shorter length. The longer one equals to x and the shorter one is equals to c. Therefore, this remaining length would simply turn out to be x minus c. Okay. Now inside this diagram, we have three beautiful right angle triangles. So let me just shade that right angle triangles in different color. So first of all, the first right angle triangle that we have is over here in the yellow color I am marking. The second right angle triangle that we have is this particular one I am shading in white color, and the third right angle triangle that we have is, you might have also guessed, is this particular very tiny one at that particular corner. Okay, so now what I'm going to do is I'm just going to redraw these three right angle triangles outside this diagram. So let us start with this yellow shaded right angle triangle that is like this way. So the right angle triangle is like this way. The height is A, the base is B. Now what can you say about the hypotenuse? So look carefully, the hypotenuse is ultimately the side length of this particular square, and the side length of that particular square we have found as 2 times the square root of 5. Now let us talk about this right angle triangle at the top in the blue color. So in that right angle triangle is somewhat like this way. Okay, here's the 90 degree, the height is C, the base is having a value D. Now the hypotenuse for this right angle triangle is ultimately the side length of this particular square, hence it would have a value square root of 5, because area of that square is equals to 5. Okay, now the third right angle triangle that we have is in the white color, so let me just redraw that one also. So the third right angle triangle is somewhat like this way. Okay, so first of all, here we have the 90 degree. The height of this right angle triangle is x minus c. The base of this right angle triangle is x minus b. Now what can you say about the hypotenuse? So look carefully. This right angle triangle has a long hypotenuse from this particular point to this point. Now the length of this thing can be calculated very easily. As I have told you, this line is a straight line. So we can simply add the length from here to here and the length from here to here in order to get the complete length. Now one of this length is already the side length of this square and the other one is the side length of the other square. So ultimately, the complete length of the hypotenuse will turn out to be 2 times the square root of 5, that is the side of this square, plus square root of 5, that is the side of the other square. And this thing will give me a result as equals to 3 times the square root of 5. Okay, so here we have just redrawn all these three triangles outside this diagram and marked the side lengths in them. Now let us mark the angles inside them. So we have already played around with the angles theta and alpha. So first of all, talking about this white triangle, this angle is equals to theta and this angle is equals to alpha. You can just cross check in this diagram. Now we are just going to play around with these three right angle triangles and everything will be solved very nicely. So first of all, we can see that the yellow right angle triangle and blue right angle triangle are similar to each other because all the three angles between them are same. Okay, so if two triangles are similar, so the two triangles are similar, we are writing it down. Yellow one is similar to the blue one and they are similar because of the property of angle, angle, angle. Okay, so once two triangles are similar, the ratio of their sides according to the correspondence would be equal. So according to the correspondence, the ratio will turn out to be somewhat like this way. B upon D equals to A upon C is equals to 2 times the square root of 5 upon square root of 5. In the numerator, I have taken the sides of the yellow triangle and in the denominator, I have taken the sides of the blue triangle. And this ratio I have taken according to the correspondence. Now let us play around with this equation. So first of all, we can see that over here, root 5 and root 5 got cancelled out. So what is finally remaining is equals to 2. So B upon D is also equals to 2 and A upon C is also equals to 2. So comparing these two equations simultaneously, we can get B is equals to 2 times D and similarly A is equals to 2 times C. Okay, so here we can see that we can just replace the variables B and A with the variables D and C respectively. So in these three right angle triangles, wherever the variable A and B are present, we are going to replace it. So first of all, talking about this yellow one, the height will now turn out to be 2 times C and the base will now turn out to be 2 times D. Talking about this white triangle, so first of all, we can see that the value of the base is x minus b. Therefore, it will turn out to be x minus 2 times d and the height will remain as it is and everything for this blue triangle will also remain as it is. Okay. Now we can see, okay? Now we are going to compare these two triangles similar to each other. We can see that all the three angles in these two right angle triangles are also same. So this time we can say that the white right angle triangle is similar to the blue right angle triangle by the property of angle, angle, angle. So once two triangles are similar, the ratio of their sides become equal according to the correspondence. So the ratio will turn out to be like this way: x minus c divided by d equals to x minus 2d divided by c, and this thing equals to 3 times the square root of phi upon square root of phi. In the numerator we have taken the side lengths of the white triangle, and in the denominator we have taken the side lengths of the blue triangle. Now look carefully in this particular equation. So we can see that in this third equation, the square root of phi can be cancelled out. What remains is only 3. So x minus c upon d is equals to x minus 2d upon c, and this thing is equals to 3. Now if I just compare these two ratios simultaneously with 3, I will get some equation. So when I compare the first one, I get the value of x equals to 3 times d plus c. And if I compare the second equation with 3, the value of x turns out to be 3 times c plus 2 times d. Okay. Now what I'm going to do is I'm just going to subtract these two equations. So when I just subtract these equations, on the left hand side I have 0, and this thing would be equals to c minus 3c, that is negative 2c, 3d minus 2d, that is equals to positive d. Now 2c can be just taken on the other side, it will become positive, and hence we will get the value of d as equals to 2 times c. So you can see that we have again reduced one of the variables, and that is d. We have got the value of d in terms of c. So as we replace a and b with the variables t and c in the beginning of the solution, as soon as we have got it in terms of another variable, now we are going to replace the variable d with the variable c. So instead of changing the variables in all these three right angle triangles, I am just going to change in the right angle triangle that is important, and that is this blue one. So in this blue right angle triangle, I can just replace the variable d as equals to 2 times c. So as it is a right angle triangle, we can apply the Pythagoras theorem, and therefore the height square, that is c square, plus the base square, that is 2c the whole square, would be equals to hypotenuse square, that would be equals to square root of phi the whole square, and that is 5. So now simplifying this thing, I will get 5c square is equals to 5, and this thing will simplify as c square equals to 1, and finally the value of c would be equals to 1. Not the negative one, because c is a side length. So the value of c has turned out to be 1. But the question is to find the area of this square, and that is x square. Now out of the 5 variables that we have taken in the beginning of the solution, that were a, b, c, d and x, we have got the value of c. Now using this we can find the value of x. So to get the value of x from the value of c, we can just take the help of either of these two equations. I am just going with the first one because it is more simpler. So first equation says that x is equals to 3 times d plus c. Now look carefully, the value of d we have got as 2 times c. So this d can be replaced with 2 times c. So the value of x will turn out to be 3 times 2 times c plus c. This will turn out to be 6 times c plus c, would give us a result as equals to 7 times c. So the value of x is equals to 7 times c. The value of c is equals to 1, and therefore the value of x will turn out to be 7. So if the value of x is equals to 7 and x is the side length of the square ABCD, this means that the area of the square ABCD is simply going to be x square, and this thing would be equals to 7 square, because the value of x is equals to 7, and this thing would be equals to 49, and this is the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, or else you can email me. I have mentioned the email address in the description.